Have you ever stopped to think about what's actually powering most of our financial transactions? You know, the stuff that keeps the world's money moving? Well, the answer might surprise you. Today, we are diving deep into a super high-stakes problem that keeps a lot of technical leaders up at night. How in the world do you modernize COBOL? It's this, ancient programming language that secretly runs our entire modern financial world. And just to give you an idea of the scale we're talking about, let's start with one number: 95%. That's right, 95% of all ATM transactions are still powered by COBOL, a language that was literally born in the 1950s. I mean, it's incredibly reliable, sure, but it's also a living fossil. And that brings us to the crisis that so many people are facing right now, this ticking time bomb that's just sitting at the very heart of their operations. Okay, so for more than 60 years, this code has been the absolute bedrock of finance. But here's the kicker. The experts, the people who actually wrote and maintained all of it, they're retiring in droves. And that's creating this huge existential threat for banks and financial institutions. There's just nobody left who knows how to manage the code. So naturally, everyone is looking to AI as, the big savior. You've got these tools like Anthropic's Claude Code and IBM's Watson X being sold as this magic button that's going to solve the whole problem instantly. But is it really that simple? I mean, this is the question on every executive's mind, right? Why can't we just copy and paste all that old, crusty code into a modern AI and just ask it to translate it into something new, like Java? Problem solved, let's go home. Well, the reality is that this seemingly simple idea is a recipe for absolute disaster. A lazy, generic prompt won't just fail, it could literally create a $1 million catastrophe. And just look at the stark contrast here between a lazy prompt and an expert one. On the left, with the generic prompt, you get code that misses all sorts of dependencies, it hallucinates financial math, which is terrifying, and it just keeps all the old problems. But on the right, with an expert prompt, you get a modern cloud-native architecture. The difference is, it's night and day. And this failure actually has a name. They call it COBOL. It's code that has the syntax of Java, but underneath it has the soul of old-school COBOL. It totally defeats the entire point of modernizing in the first place. You're just left with the same monolithic mess, but with a new coat of paint. So here's the crucial point. You just can't be lazy. You need a structured, expert-level prompt. So let's break down the anatomy of what a perfect prompt actually looks like. And it really boils down to these 4 key parts. First, you have to tell the AI its specific role. Then you have to give it all the necessary context. After that, you define a very precise and isolated task. And finally, you apply super strict constraints on the output. Every single one of these steps is totally non-negotiable. For example, just look at this role definition. It's not just act as a coder. No way. It's incredibly specific. You are an expert mainframe architect. You're telling the AI exactly what kind of expert it needs to embody, and that just dramatically improves the quality of everything it produces. All right, let's get into the advanced playbook and see how this all builds out. This is where we start to tackle the really thorny parts of the modernization problem with some serious surgical precision. See, your COBOL code doesn't just exist in a vacuum. A generic prompt will completely miss this complex web of external dependencies it relies on. Things like JCL, which is what controls how jobs are run on the mainframe, and these things called copybooks, which define data structures. If the AI doesn't know about these, the code it spits out is going to be completely useless. So the solution is this really powerful technique called RAG, or Retrieval Augmented Generation. What you're basically doing is giving the AI your entire library of technical documentation to read before it even starts the translation. It's kind of like letting it study for the test. Okay, now for what is maybe the most critical part, the financial math. An AI, which is probabilistic, can make these really subtle rounding errors that could be absolutely catastrophic. To prevent that, you have to use these explicit constraint prompts, just like this one, leaving zero room for error. It has to be deterministic, period. And look, you can't just trust the new code. So the final piece of this puzzle is to actually prompt the AI to write the unit tests itself. These tests are based on the original COBOL logic, which lets you prove, mathematically, that the new Java code works perfectly. Okay, finally, none of this matters one bit if you can't do it securely. And that brings us to the non-negotiable governance framework that you absolutely, positively must have in place. Let's be crystal clear about this.
Pasting proprietary banking code into a public consumer-grade AI tool is a massive security breach and a regulatory nightmare waiting to happen. You have to use enterprise-grade private AI instances on platforms like AWS Bedrock or on-premises solutions like IBM Watson X to keep your data safe. So here's the big takeaway. AI gives us an incredibly powerful path forward for modernizing these old legacy systems, but it is not a magic button. It requires real expertise, precision, and a rigorous process. Which leaves us with a final, kind of provocative question to think about. Is this the tool that finally tames legacy code for good? Or are we just creating a whole new generation of technical debt that we don't even understand yet?